That's what it's for. That's why the outline is the most important piece of the paper besides your test. So, outline, test, book, homework. Okay? That's the way it should go. Even though still 5 or 6 of y'all aren't going to listen to me. All right. So I want to go over this one more time so that way the one person that watches the video because they're not here and sends me a text, what did we go over in class? I have no idea. Where's my markers? Somebody keeps putting these markers in a hiding place. Okay. I'm going to write this down just so everybody will know. 20% of the next test, unit what? 2. Let me just write that up here. Unit 2 test, 20% will come from 4.1 and 4.2. And 80% will come from 5.1, 5.2, 5.3, and 5.5. Now, just so I know this is correct, look on your outlines. And the outline should say probability, and then the additive law, and then the multiplicative law, and then counting. Somebody verify that we're all on the same sheet of music. Yep. Okay, so 5.4 and 5.6, we're not going to do. Okay? So I would really focus on the problems that we're working on now. When we're talking about the 4.1 and 4.2, I'm going to ask you a question like that. I'm going to ask you a question like this, or it'll be on there somewhere. I'm going to ask you a question like that. I might ask you to find the slope, and I may ask you to find the R factor. Okay, so there's 5 possible questions I can ask. I can ask you to calculate the slope. I can ask you to calculate the R with what? Your calculator / Excel. Okay, so you're going to have to learn one of them. All right, I don't care which one you learn, but you're going to have to use one of them. Either bars, bags, field, calculator, or put one on your phone. Okay. Slope, you can do that by hand. And let me just draw a line right here. And point slope equation. Okay. We went over all of those things in 4.1 and 4.2, so you need to check that video out if it's up. Hopefully it's up. I put them up every day, hopefully. I hope I do. Try to. Unless the ones that we get way off chasing rabbits and then I don't put it up. Okay? 80% of the test will come from probability. So if you're talking a 20 question test, you're talking 4 to 5 questions from 4.1 and 4.2. The rest of them will be from 5.1 through 5.3. You're only talking about 15 questions though, because I give you those 10 or 15 bonus questions that some of y'all ignore. Okay? So you're talking about maybe 3 or 4 questions or 2 to 3 questions from 4.1 and 4.2, and then 10 to 12 questions from 5.1 through 5.5. Okay? Mm-hmm. All right, so do you click on 5.4 and 5.6? No. Do you worry about 5.4 or 5.6? No. Well, Hubert, what about the grade? I'll take care of that last week class while you were taking final exams. Okay? Simple as that. Some of y'all are like mama hens. Y'all worry too much. Okay? If I put an X through 5.4 and 5.6, that means you can just delete it from your mind. You can delete it from the outline. You can delete it from looking at it on the homework. That's what that means. Okay. Now, let's look at handy dandy slides and see if I've covered everything in 5 point whatever. Okay, because 5.1, we went over probability outcomes. Let's go to I want to see 5.2. 5.2, the addition rule. We don't go over Venn diagrams because that's not what I'd rather you cover a table than a Venn diagram. Okay, so use the addition rule. This is pretty simple. If they ask you for the probability of 1, 2, or 3, you add those 3 up. Okay, it's not that big a deal. I'm not going to worry about that. I want you there, 2 and 3. Okay, and what's the word? What's the key word? Or. So you need to, maybe write this one down. Just write it in your notes. The reason I want you to write it in your notes is because there may be a problem on the test about jurors. Okay, it uses the word Mexican, which I don't know why that offends people. If you're from Mexico, you're Mexican. If you're from America, you're American. So I don't understand why people don't like the word Mexican. If you're from Canada, you're what? So what's the problem? But anyway, I think it's either in this class or the 103, there's a question on there about Mexican jurors, okay? And they say, what is the probability of 2 or 4 or 2 or 3? And you take the 2 or 3, in this case it's 2 or 3, and you just add them together. Remember, I want you to write that question. What is the probability of random selection? And then I want you to highlight the circle that word or, because that's where you're going to see the word that tells you to use the additive law or the multiplicative law. Now it's pretty simple. So I'm not going to really cover it because, like I say, it's pretty simple. But if you see it on a test, you might not know what to do if I didn't show it to you. Question? Yes, ma'am.
I put down the notes I really like on the video on YouTube, and on here it's dividing the like you add
odds. That's the only place we divide. It's on odds. Is that where you're talking about the odds? Okay, go ahead. Go ahead with your question.
Like when it was you did the blood types.
Mm-hmm.
And it was
okay.
A or B or something, and then put it over 72, which is the sum of all.
Yeah, that's a different type question. This one they've already done it for you. Okay, this one they just put the probabilities out to the side. Totally different question, but that's a good question because I guess that's why I'm showing you this question. It's because they've already done the probabilities over there on the right hand side. Okay, and the question that she's asking where we did the blood types, they don't have the probabilities. That's what you're finding. Okay, so you're finding those numbers over there on the right with that question about the blood types. This one, they've already done it. And they're just saying, and you just add them up. That's what it's kind of the same concept, but the delivery is totally different. The question is totally different. Y'all got it? Okay, you should have it by now. I'm glad I went through. That's why I go through these PowerPoints to make sure I covered everything. And then let's see, 1, 2, or 3. And they can ask 1, 2, 3, or 5, or 8. And then you would take those individual probabilities and you add them together. Simple as that. They've already done the probability. Now here's an example of the sum of less than or equal to 5. All right? Now, the sum of the dice is less than or equal to 5. That I would use a complement here. Why? Because it's easier. What's the complement? Now this is a good question because it actually tests you to see if you can think. What is less than or equal to 5? Everything but one what? Die. And which one is, okay, I'm sorry. I thought it was just one die. It's 2 die. Okay? Look at the die and tell me which ones, and you'll see a pattern. That's why they got them in this area. All right, look at 5. Okay, 5 is 4 plus 1, then 3 plus 2, then what? 2 plus 3. And you'll see the pattern. Less than or equal to 5 is right there. Somebody check me and make sure I'm right. I don't see any more. Okay, how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of what? Well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 36? So that'd be 10 out of 36. But you gotta find them. I thought they were asking one die. And then that would be, if it was one die, what's 5 or less? Well, it's the complement of 6. Think about it. Complement of 6 is what? 5 or less. Anyway. So if I ask for one die, what is the probability of 5 or less? You would not figure 5 or less. You would say the probability of 6 subtracted from 1. The probability of 6 is 1/6. So what would the probability of 5 or less be? 7/6. Using the complement. Okay, anyway. So in this case, 10 over 36 would be the sum of the dice addition to blah, blah, blah. Now they're asking for using the probability of the great additional or the addition rule, and you can do that, but I just did it in my head using these two right here. But that's up to you, how you want to do it. Okay? That ain't what I'm really wanting to get to. I'm wanting to get to a table, and they haven't even put one on here, so we're just going to continue with the table. I'll give you another table out of the homework to go in your notes. Okay, here's where we left off the other day. We left off with independence, and did we go over the marble bag? I didn't hear you.
Yeah.
Okay, we did. Thank you. That's kind of like walking up to somebody's door and doing this. It irritates me. I just ignore them. And eventually, after about 5 minutes of doing this, they finally do this. That's the way you knock on a door. You don't say yes. I'm looking for one that I like, that I've put on a test. I don't see one yet. What?
I was wondering what her coffee smells.
Okay, I don't like any of these questions.
That's what it smells like.
All right, it says right here, that's 5.4. I'll just make up some questions. I'm going to make up some questions for addition and multiplication. I don't like theirs. Okay, here we go. 5.5. This is where we get into probably out of the 80% of your test, you're probably talking about 50% of the 80% is going to be from this section right here. Okay? So you're probably talking about 5 or 6 questions from the counting. Now, what is counting? The counting technique is using factorial. And most of you, since you are in high school, well, I use that term loosely because sometimes high schools don't teach you squat. Use factorial. All right? Can somebody give me the definition of factorial? No, I didn't ask you to describe it. I want you to give me the definition. Just think of it as an SAT question. Multiplying the numbers respectively as they fall into our number sequence. Okay. I know, this is the gas, residue of the gas, right? So multiplying numbers in their sequence, natural sequence. I would put natty, but some of y'all are alcoholics and y'all know what natty means, so I'm not going to put natty, I'm going to put natural. Okay? Multiplying numbers in their natural sequence, blah, blah, blah. Here's an example. 5 factorial is what? 5 times 4 times 2 times 1. I'm sorry, I'll just skip 1. Times 3 times 2 times 1. Why do I not multiply by 0?
Because anything comes 0 is 0.
And you would cancel, there would be no reason to have factorial because 0 would cancel out every factorial that you do. So you have to exclude 0. And you might want to write that down over here. Excluding 0. Okay. So 5 times 4 is what? 20 times 3 is 60 times 2 is 120. So what would 6 factorial be? 720. What would 8 factorial be? I'm sorry, 7 factorial. Well, 7 times 720 would be 4940 or 5040. What would that be? Somebody multiply 7 times 720. What do you get? 5040?
Yeah.
Okay. So, and it goes on, and you'll see the pattern. If you do 4 or 5 of them, you'll see the pattern. You just multiply by the preceding number, or the number that's after. If it's 5 factorial, then you multiply 4 factorial times 5. 5 factorial would be 5 factorial times whatever. You'll see it. Okay? So, this whole thing, this whole chapter is based upon this guy right here. So don't let the number, don't let the title fool you. It's not counting like 1, 2, 3, 4, 5. It's counting using factorial. Nothing's free and nothing's that simple. You're in college. You're not going to come up on a whole chapter where you just count. Okay? Unless you're in gender studies or underwater firefighting or what is it that chick in New York, global studies. Stay away from degrees like that. Stay away. Stay away from them. Why? Because you won't get a job. They're made up. They're made up to give people a degree, to make them feel good about themselves. Kind of like Parks and Recreation. But at least you can get a job at Parks and Recreation in a hotel. You know what I'm saying?
That's the fastest growing majors in studies.
Wow.
Wonder why.
Crazy.
Wonder why. How much math is in it? Look it up and see how much math is in it. Probably probability and statistics. And that's what they're fixing to tell you right here. All right, here, ordering such a meal requires 3 separate decisions. Let's go ahead and look at the question. I'm not going to ask you this question, but you need to look at it. All right, write it down. A fixed dinner at restaurant, no sneezing in class, provides the following choices. Appetizer, soup or salad. Every time I see the word super salad, there used to be a super salad right across from West Side. And the football team put it out of business. We go over there to buy 1 plate and pass the plate around. And we shut that place down. Used to be right across there, right where the Ingalls was. There used to be right across, right beside that, what is that, emergency? There's a doctoring place over there where you get fixed up or whatever. It's right beside there. Anyway, we put that place out of business. It's called Super Salad. We ran that place out of business. Baked chicken, broiled beef patty, baby beef liver, roast, whatever. Okay? Ice cream or cheesecake. How many different meals can be ordered? There. 2 times 4 times 2. You just multiply the 2 courses times 4 courses times 2 courses. Simple as that. Now, I'm not going to ask you that question because I think that's a real stupid question. All right? I'll tell you when a question is stupid, and I'll tell you when it's applicable. This one's stupid. Nobody's going to sit there and say, well, I wonder how many different orders I can make up. When you go to a restaurant, what are you usually? Hungry. Okay? You're going to order an appetizer. You're going to order a drink, a beverage, whatever. You're going to order a meal, and you might, if you're hungry enough, and you don't eat too much of the bloomin' onion or the chili cheese fries. That's my favorite restaurant. Okay, if you don't eat all that and get full, you might order a brownie and ice cream or whatever they make, that big old brownie and ice cream, whatever they do. That's good. All right. Nobody's going to sit there and say, well, let's see, they have this many appetizers, they have this many entrees, and they have this many desserts. How many combinations do I have? Really? You're going to sit there and ask that? you don't need to be out. You need to be back home. Okay? Here is where we get n factorial. N factorial is the number multiplied by in the sequence that it's in, period. Okay, here we go. A permutation. Now, I'm not going to make you memorize that formula because it's very tedious. You will use your calculator and Excel to do it. It's very simple. Even if you don't know how to use Excel, all you have to do is type in something and boom, it'll give you the answer. You don't have to type in the numbers. You don't have to type in a chart or anything. All you got to do is go to Excel, type in permu, and then equals permu, and then I'll show you how to do all that. Okay. Same thing with combination. It's combine or combine. It's not an E in there. Okay. So I'll show you how to do that. Write the formula down for your own information. But a permutation is when something is in order. Okay. There it is, number 3. Highlight that word order. Whenever you hear order or see order in a question, the horses in 1, 2, and first, second, and third place, that's order. Okay? The cards are in ace, king, queen, jack. That's in order. So you're doing a permutation versus a combination, which doesn't say anything about order. And we'll get to those. And I'm going to give you about several of each of those questions to where you can see the difference between the two. Okay? But as far as learning the formula, you only have to learn the formula for your own benefit because you can do it on a calculator. But if I did give you a question of 5 permutation of 2, okay? 5 permutation of 2, it would be written like this. And you would type in, what's n? What's n? N is always your biggest number, Hubert. That's right, 5. So that would be 5 factorial over, what's 5 minus 2? 3. Now I'm going to show you a trick I learned in the war. 5 times 2. 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And what happens to the 3 2s and 1s? You're left with 5 times 4 factorial. Okay? But it's not easy to do that in your calculator. Okay? So what I would suggest you do is use the formula. Okay? Or you could do, that's a yawn, I saw that. 5 times 4 times 3, we said is what? 120, right? So that's 120 over what? 6, Hubert. That's right, class, which is equal to what? 20. Yeah, that's right. So your answer to this question is 20. Yes, ma'am.
There's a quick NPR or NCR.
Yeah, I'm going to show everybody that on the calculator. It's under math and probability. We'll get to that when we do a problem. I'm not going to do it yet until we get to a question, and then we'll do it probably on the next slide. There we go. Up, look. I cannot believe this. I don't memorize these slides. It's the trifecta. This is a standardized test question. This is a question that'll be on SAT, ACT. Okay, there are 10 horses in a race, blah, 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 blah. What is the chances of taking 3 at a time or whatever the finish line in a race? Okay, so there's 10 horses. They want to know the top 3. So write that down. 10 permutation 3. And write the question down and put a star beside it. This is a test question, a homework question, and a standardized test question. No Steeson in class. Now, let's pull up our handy dandy calculator and spreadsheet.
I have a question.
Nope, I'm not on the clock right now. Yeah,
So basically what we just did in that last one is figure out how many different ways, orders they could cross things on.
yep.
Alright.
And as we do these problems, you're going to see what it's asking, especially when you see, and the best example is the officers and committee. That's the best question because you actually see the difference, okay? And we'll talk about it in class. So I'm going to take the Excel spreadsheet first, and I'm going to show you how easy it is. Type in equals, P-E-R-M, and there it is, permute. Now write that down. P-E-R-M-U-T, permute. And hit enter. Oops, sorry, I messed up. Equals P-E-R-M-U-T, and parentheses, 10, comma, what was it, 2, 3, and boom, there's your answer, 720. Equals, and I'll put it back on the formula there it is. That's how you type it in the Excel spreadsheet up at the top. Equals, make sure you type in the equals because the equal sign tells Excel, okay, this is a mathematical formula. Okay, equals, permute, without the E, permute, parentheses, 10, comma, 3, close parentheses, and hit enter. I'm going to go ahead and show you combine. Combination is C-O-M-B-I-N. There it is, combine, sorry. Parentheses, 10, comma, 3. 120. So I'm going to give you those two again. Equals combine, 10, comma, 3, and permute, 10, comma, 3. So those are the two designations that you're going to use for the formula that was on a while ago, and I'll explain combination in just a minute. Now the handy dandy calculator. Oh, really? All right. You type on first, and say, I believe it's math, probability, but you have to type in, number 2 and number 3. Math, probability, number 2 and number 3. Probability, and you have to type in the numbers. I thought we did. So I would type in 10, math, probability, NPR, and 3, and enter. Now the good thing about this, hit second entry, and you can pull it up again and change the numbers instead of going through all that. Second entry is second enter, and I can change it to 12, 15, 5. Okay. Shift, enter, and I can change it to 25 and 1, which should be 25. Okay. And combination, same thing. 25, math, probability. I hate this calculator. Down, combination of 6. So combination and permutation are always together, whether it's on a calculator or whether you do it on a spreadsheet. They're right there together. They're about the same for the formula, or just one thing different between the two formulas, and that's R factorial, I think. Okay? All right, so we'll keep doing this with each question. And after about the fourth or fifth question on both, you'll understand the difference between the two a whole lot better than me explaining it to you mathematically. Okay? So let's go back to the handy dandy. What?
Nothing, I just noticed something.
I'm going to have to close the windows. You're just like my son. Just like him. I put blinders on him. A combination is a collection. They're NCR. Okay? Without what? Order. Put that down. Combination, no order. So that's the difference between the two. And there is the formula. And see, the only difference is, I thought it was R factorial. R factorial is the only difference. And it's in the denominator. So you're multiplying by another digit. So that means that's going to make the denominator bigger, which makes the number what? Smaller, Hubert. That's right, class. The bigger the denominator gets, the smaller the number gets. Right? 1/2, 1/4, 1/6, 1/8, 1/10, 1/15. Get it? Some of y'all are just looking at me like I'm retarded or something. All right, write this one down. How many different random samples of size 4 can be obtained from a population whose size is 20? What is always your biggest number? N. So that question tells you what N is, even if it doesn't say what N is. N is always your biggest number. You don't have to write down that whole paragraph. Just write down the first sentence and then look at the formula or punch it in your calculator, or if you got a laptop, well, most of y'all have those things, which are about useless. Anyway, and y'all can't get Excel. That blows my mind.
For some reason, on some of them you can, and like some of the homework questions, it'll let you do like all the math stuff, and then some of them won't, and I don't understand.
But Excel is not on that Chromebook.
It's called spreadsheet, but like, I don't know if it's the same thing.
It's called what?
It's called, Sheets, Google Sheets or something like that.
It's the Google Drive version of.
Yeah. Okay. Hopefully it's like Excel. Maybe it's Excel and put in Google terms. Maybe. I don't know. But I hope it works the same way. If it doesn't, then they're stupid for using it. Yes, ma'am.
Okay, so when you plug everything in and it's 4 factorial of like the 20 minus 4, then factorial again. Then it's 4 factorial times like the parentheses 16. Do you go ahead and put the factorial beside 16 and then you multiply?
Yes, up to you. The 4 factorial, just like they've got it right there, means 4 times 3 times 2 times 1. Yes, you can do it like that. Yes. There's only, when you have 2 factorials together, you have to basically put them in parentheses. Just do the parentheses and I'll make it easier. Okay? And 4 times 3 times 2 times 1, basically you can cancel the 16s out. Do y'all see that? The 16s cancel out, so you don't even need them. Right here. And that's if you do it by hand. The 16s cancel. And therefore you're left with 116, 280 over 24. It's easier just to do it like this right here in your, this is the easiest way to do it. If you don't use the NCR in your calculator, okay? Yeah, NCR or NPR. If you don't use your Excel spreadsheet, the easiest way is to type this in your calculator. And as long as you have a scientific calculator, you should have factorial. You just got to find it. Okay, now of course the TI-84s and all them have it. I'm saying if you look on your phone, flip it to the side and turn to the scientific calculator, there should be somewhere on there that has a factorial. Factorial is pretty standard on a scientific calculator. Scientific and graphing, 2 different animals. Scientific is a little $30 calculator that you get that doesn't have a big screen on it. That's a scientific calculator. You got it?
Well, I don't know. Hang on.
Oh, just forget it.
Oh, yeah, I got it.
Okay. So you would type in 20 factorial over 4 factorial and put that in parentheses. You do 4 factorial in little parentheses times, what is it, 16 factorial? And close parentheses, and then you'd have to put another set of parentheses like that. So it'd be parentheses 20 factorial divided by parentheses 4 factorial, close parentheses, times parentheses 16 factorial, close parentheses, close parentheses, close parentheses. And that's another way you can do it. All 3 of those are a whole lot easier than doing it by hand. Okay? I'm hoping they get to the actual questions because. All right, this one is another standardized test question. I think it's stupid, but I'm going to show it to you anyway. How many different vertical arrangements are there of 10 flags if 5 flags are white, 3 are blue, and 2 are red? Again, it's a combination, okay? Okay, since it is doing an order, we use the permutation, and that's going to be this is just using factorial. This is not the permutation formula. It is just a permutation. I don't like to use that word. Okay, so just use the factorial. Just use factorial. It would be 10 factorial over 5 factorial times 3 factorial times 2 factorial. So the 10 would go on top. All right, there's 10 flags. The arrangements go on the bottom. All right, so write that down. Just write this sentence down right here. They might do this. No, they're not going to do it with a license plate because the license plate is exponential, and I don't know why we haven't seen that yet. License plate is usually in here, but I haven't seen it yet. How many different vertical arrangements are there of 10 flags? That's n. So it'd be n factorial over just the rest of them multiplied together, factorial. Yes, ma'am.
At the top, since you only stopped at 5, but you still put the exponential thing, does that mean it keeps going to 1?
Yes.
Okay.
But you can cancel these 2 out because 5 factorial and this is 5. No, you can't because this doesn't go to 1. All right, it does with 2 times 1, but it doesn't like 2, but 1 doesn't make any difference. Yes.
Okay, so when you're talking about canceling all the stuff out or whatever, can you cancel out the 5 factorial one and just make it 3 factorial times 2 factorial?
Yes.
Or would it be easier to cancel out?
No, I would. You got to be careful here because this does not mean, yeah, it does go all the way down to 2. Yes, you can cancel 5. Yes, you can cancel them. Again, I don't use this question very much because, like I say, is this something that you're going to do for the rest of your life? Probably not. Okay, but will you gamble? Yes. Will you ask about horses? Yes. Will you ask about lottery? Yes. Okay, will you ask about committee members and board members? Yes. So those are the questions that I stick to. Horses, lottery, and committees and boards. Which, of course, that's not what's on here. But there we go. And before we do this, let me make sure because I start seeing people fidget. Okay, we got plenty of time because it's only like 8 after and some of y'all are already fidgeting. All right, I'm not going to do this one. I'm going to go to the South Carolina lottery. Okay, so we're going to get out of this and we're going to go to the South Carolina Education Lottery. South Carolina Education Lottery. And Powerball. Oh, just in case, if you were able to win both of the 2 lotteries, you would be a what?
Billionaire.
You'd be a billionaire. 345 million plus 654 million, 664, that'd be close to $1 billion. Okay?
max is, so.
20%. I'd be glad to give them 20% of $1 billion. Yeah, give them 20%. That's fine.
Give me the.
Yeah, I'll take $1 million. I'll just take $1 million, you know. But they asked me when I buy my lottery tickets, do you want to double up? I said, no, I'm fine with 300 million. But that don't go to the grand prize. That just goes to the lower prizes. Like if you win $5, you win 10. But it doesn't go for if you won 300 million, you're not going to win 600, 700 million. It doesn't work that way. But anyway, go to Powerball and go to how to play. And I want you to write these first 2 paragraphs. You don't have to write it word for word. I'll blow it up a little bit for you. Just write it down because this is a test question. And you bet your bottom dollar I'm going to ask you about the lottery on a test. If not 2 questions. So, now of course you're not going to write down the whole thing. Okay? You only got to write down the first paragraph. It says, select 5 numbers from 1 to 69. Write that down. And then it says, select 1 number, 1 to 26. Write that down. That's all you got to write down. Select 5 numbers, 1 to 69, and 1 number, 1 to 26. Okay, because the Powerball, how does it work? Well, they pull up. Let me get my handy dandy whiteboard. The Powerball, they get in this air compressor and this basically ping pong bowl, fish bowl, whatever. And it's a box, and it's got air going into it, and it's got a little chute right here, and a little cage thing right here. And what happens? All the ping pong balls are going all over the place, and then they just open this little thing up, and one of the ping pong balls goes, zoop. Okay, that's how it happens. All right, have you ever seen it?
Yes.
Okay, good. All right, they put 69 in this box, and they put 1 through 26 in this box.
Oh, that's the multiplier.
Okay, and you've got 5 balls that come out of this box. They draw 5 balls and then 1 out of this box. So if you match those 5 balls or 5 numbers and this number, if you match all 6 of them, you're a billionaire or a millionaire. Okay? So, how do we do it? Well, first of all, and you need to write this down, to win the lottery, you have to what? You have to play the lottery. Now they say, what does that mean? You have, and underline the word have, to play the lottery. Meaning that you have to buy a what? Ticket. So that means that all your answers are going to be at least over 1 or under 1. Why? Because that means that you bought a ticket. Now what if the thing says you bought 10 tickets? Well, instead of 10, it would be 1, it would be 10. If you bought 100 tickets, it'd be 100. Okay? Now, that's what gets a lot of people on tests. Okay? It's assuming that if they ask you what is the probability of winning, it's assuming that you're buying 1 ticket at least. So if you don't put that 1 right there, are you going to get it right? Nope. So you have to put the 1 right there, unless it signifies that you're not playing, or whether it signifies more than 1 ticket, like 10 tickets. So you have to be careful with those questions. Some of them I disagree with on the test, and I will give you credit. If it is vague, I will give you credit for it, because some of them don't write the question down right. They're supposed to say, what is the probability of winning the lottery? When it says winning the lottery, that's assuming that you bought at least 1 ticket. Okay? Dang old Willy Wonka, dang old golden ticket. All right. So, what do we do? Well, does it say anything about order? No. So this is a what problem? This is a combination problem. What's n? 69. 69 combination 5 times what? 25 combination 1.
Well, it would be 25 and 26.
What did it say? Oh, 26, sorry. Think you smart, don't you? What that gas do, expand your brain?
So what did the second one just be 26?
Yes, it's always gonna be that single, yeah. All right, but they could say 2 Powerballs, and then it would be 26 combination of 2. All right, but they don't ever do that. And that's gonna be, so somebody do that in your calculator. And I'll do it on the handy dandy spreadsheet. 69 combination of 5, 25 combination of 1. Now we're going to stay until 9:25, okay? Because I'm going to show you something. So don't be rude and start getting the zipper fetishes, all right? So I'm going to put 1 ticket. Oops. 10 tickets. 25 tickets. 100 tickets. 1,000 tickets. 1,500 tickets. 2,000 tickets, 2,500 tickets, oops, 5,000 tickets, 10,000 tickets, 25,000 tickets, 50,000 tickets, 1 million tickets, and 2 million tickets. Yeah, things I do for y'all, make it bigger and forget to bring it down. Now, okay, now we'll go over here and I'm going to put, well, I got to go up here and I got to say N equals, what do we say, 65 or 69? And R is equal to 5. And then N is equal to 25. And R is equal to 1.
It's 26, not 25.
Thank you. Okay, so right here we're going to go, okay, equals, and I'm going to take this number, and I'm going to divide by parentheses, and this ain't going to work. Nope, that ain't going to work. I'm going to do come bin, parentheses, this guy, comma, this guy, close parentheses, and then I'm going to equals, same thing, come bin, parentheses, this guy, comma, this guy. Of course, that comes out to be 25, and I know that. I have a degree in everything, so I know that. Now, if I take these numbers and well, what I should have done, let me hit Control C, and I bet it won't do it. Control V. Yep. Hold on a second. Let me fix this. Did I just see you do what I think I just saw you did? Okay, thank you. Hey, we're going to take up a collection for you at the next class because I think you need some medication or something. Okay, because yeah, no, you don't have to. You don't need to say anything. We're just going to have a group intervention right here and take up some money for you. All right, here we go. You ready? So I'm going to buy 1 ticket. The golden ticket. All right, parentheses. This times this. Really? I'm starting to get irritated. Hold on. What is that? M1, N1? And I've got 6 minutes for those that are already starting. You're already starting. I can hear it. Divided by parentheses, this guy times this guy. Close parentheses. I better hit F4 on both of them. F4. And I want to hit here, F4, and close parentheses. All right, y'all ready? Now, for those of you that are paying attention, okay, I'm going to copy this down. And what does that mean?
It'll be not all the way from,
And it's not supposed to. It's not supposed to do that. Let me try it one more time. 1 divided by parentheses, this guy times this guy. I don't know why it's doing that. Let me try this. Yeah, it's not going to do it. Maybe I ought to just put it right here and see if it does it. I don't think it's going to do it. But I've done this like every semester, and F4, and for some reason I'm having a, there we go. No, that's not right either. Well, what it comes out, what it's supposed to come out to be, it's supposed to be 0 all the way down, and it's not doing it, and I won't do it again because I know that it's the reason it's not right is because I've only got like 6 minutes, and some of y'all start to go in y'all's convulsions. So that's why I just might as well wait till the next class. There it is. Okay. So, and there's a guy named Joel Brawley. He was one of my professors at Clemson, and he wrote 2 books on this theory called Gambling Theory. And Bubba comes in and buys 1 ticket, and Bubba number 2 comes in and buys 2 million tickets. Who's smarter? Bubba number 1. Why? Because what's the probability of winning with 1 ticket or 2 million tickets? 0. Because we always round to the 100th place, right? Or the 100s, yeah, hundreds. So what is it with 1? 0. What is it with 2 million? Maybe, or 1 million. 0.00. So you have the same amount of chance of winning the lottery with 1 ticket or 1 million tickets. Now, that goes to the question, if you've got 1 million tickets, if you've got $1 million that you can just throw away, why are you trying to win the lottery anyway? Okay? That's number 1 logic question. Number 2 logic question is, who is smarter? Bubba that buys 1 ticket or Bubba that buys 1 million? Bubba that buys 1 because he can win the same amount as with the 1 million. Now, somebody says, well, that's really 0.003. Not by our standards. We go by the hundreds. Okay? Think of your money. Do you carry your money to the 10,000th digit? No. Even though there was a guy that worked at the World Bank, and he was shaving off the last 8 digits of everybody's money, and by the time they called him, he had $2.3 million in his little savings account that he squandered away. It took him 2.5 years to catch him because he was a programmer, and he was just letting everybody have their money to the 10,000th digit, but he was taking the rest of it. So imagine taking your penny and dividing it into 32 pieces. He was taking about half of them.
oh jeez.
Okay? Now, the World Bank, we're talking not pennies, we're talking millions and billions of dollars, okay? So each one of those pennies, those 32 seconds of a penny, he was putting in his bank account. By the time they called him, he had $2.3 million in his own little bank account.
But did he lose?
He lost it, of course, he went to jail. Okay? So we don't carry our percentages to the 100,000th place. No, we don't. We carry it to the 100. And those percents, if you want us to change those, here you go. So, who's smarter? Buying one ticket or 1 million? Buying one. All right, y'all get out of here. Have a good day. Y'all can start working on the probability section. If not, we're going to finish it next time so you don't have to really. I need you to do 5.1, 5.2, and 5.3. You need to be working on those, okay? Y'all have a good day. Glad y'all got to see me today. And take some medication.
Too late. Oh, sorry, Mary.